stuff though. Change their minds. Okay, so here's graphing. Let's talk formulas. When you have constant velocity, you have specific formulas for constant velocity. Those include that average velocity is displacement over time. Does that still hold true for constant acceleration? Yes, but when we have constant acceleration, we don't often talk about average velocity. We instead care for constant acceleration about velocity at a given point in time. When I have constant acceleration, I have a way of finding my final position. Final position is average velocity times time plus initial position. And this comes directly from this formula because displacement, which is equal to final position minus initial position, is equal to average velocity times time. Yes?
What was the second formula you just put up there for?
Final position is equal to average velocity times time plus initial position, which comes from here. And that came from here. Alright, let's finish our constant acceleration formulas. Well, if I have acceleration, let's put up the definition for acceleration. The defining formula for acceleration is that acceleration is a change in velocity over a period of time. This then leads us to say that acceleration times time is equal to a change in velocity. And because I know change in velocity means final velocity minus initial velocity, I end up with this formula for final velocity. Now, I can't find final position anymore by using an average velocity because I don't care about it anymore. I care about my acceleration. So when we're talking displacement with constant acceleration, we say displacement is equal to initial velocity times time plus half the acceleration times time squared. This we get from calculus. So you just have to accept the fact that I'm not lying to you and that this is how you can find displacement. And then remember the fact that displacement is final position minus initial position. If I plug this fact into this equation, then I get my final position equation as initial position plus initial velocity time plus half acceleration time squared. We didn't explicitly state this in class. We simply left you at displacement equals. But if I'm looking for a final position, it equals this. I just take my displacement and I add on my initial position. Displacement tells me how much my position changed, and if I want to know my final location, then I take my change and add on where I started. Yes?
So are we going to know how to convert these for certain problems on the test?
You don't need to know how to derive them, but you should know their basic definitions and be able to apply those definitions.
Okay.
Yes?
Wait, are those all the exact same ones from the book, but you just derived them differently?
Basically, yes.
So we don't have
Let me circle the ones that you're used to. You're used to this. Or at least you better be, because if you've done your homework, you're used to these. You're used to those ones. You are used to this one. I'm simply giving you more meaning for these equations by mixing them together. You are used to this equation, and you are used to this equation. Simply trying to give you more meaning by mixing them together. If you know the ones in the box, plus one more that I need to show you, the shortcut equation. If you know the ones in the boxes, then that's what you need to know for the test. I would hope that through the course of this year, you become more comfortable with the fact that you can plug in what change means. And you can solve for the two sides of the change, the starting point and the ending point for your change. Yes?
For the practice text we were using today, one of the questions was write an equation for the position of at any time. We have this.
So you can easily find displacement. You know how to do that? Well, the only way that you can go from displacement to current position is to add your initial position. So it was fairly ambitious of us to ask you that question and expect you to know how to do it. It was ambitious of us. So where might you see something like that on the test? Okay.
for which question?
You see to me tomorrow, right? It'll make sense tomorrow. Sorry?
What number was that?
Well, you'll have Miss Lance and you'll take this thing tomorrow. Because I don't teach her, so she's pointing at stuff that.
What number was
I
that?
don't have
5B
colored
today?
paper.
Hear me?
I didn't really explain anything either.
I don't know, but I got it on video.
Okay.
Here's
There's one more equation. It's the equation that I call the shortcut equation. The shortcut equation allows you to find displacement without needing time. And, children, the shortcut equation is that final velocity squared equals initial velocity squared plus twice the acceleration times displacement. This allows us to skip the step of solving a quadratic to find time. It is a shortcut equation because it allows us to skip a step. Okay, if I give you initial velocity, final velocity, and acceleration, then you don't have to go up here and find time. Or if I give you a displacement and acceleration and initial velocity, and I want you to tell me final velocity, then you don't have to take this equation and solve the quadratic. Okay, might you have to solve a quadratic on the exam? Sure. Hopefully your math classes have prepared you for the fact that you know how to solve a quadratic. See, there you go. The math steps are the less important on this test. Keep in mind, I care more that you're applying the physics knowledge that you have. Okay, if you solve a quadratic wrong, that's just a math mistake, 1 point off of 5. So hopefully you don't do a math mistake in every single problem. That would be depressing. It would be very depressing. Okay. Before I find something else that obviously I've skipped because I skip stuff sometimes, what questions